I've got some different examples of different types of questions that are coming up on GCSE Physics on the new specifications. I'm going to take you through how to approach them. I'm not going to tell you the answers. I'm going to do that cruel teacher thing where I don't give you the answers until you have had a go. So I want to see your answers in the comments to these questions. I'm going to give you a bit of advice on how to approach each of them, and there's a different type of approach to different types of questions. So I hope this is going to make you really, really resilient. If you have a go, and if you help each other out, maybe saying why you think it's this answer, not this answer. If you do that, then I will post a video where I go through the answers to these questions as well. Okay. This is an MCQ, which means multiple choice question. It's the foundation tier 1. And my advice for multiple choice questions is always try and answer the question without looking at the answers. The reason for that is 3 of these are distractors. They're answers which seem right but are not right. Once you have answered the question, then go ahead and check the other answers and try and convince yourself why you think they're wrong. So try and eliminate them after you've had a go at answering it without looking at the answers. This is a higher tier multiple choice questions. This time you are going to need to think, well, what are they asking me to work out? But again, multiple choice questions, try and work it out before looking at the answers, because some of these are placed here to distract you. So this is a new type of question in the new GCSEs, which is about a practical. It's about a PAG, a practical activity group, a practical that you will have done in your lesson, or you will do by the time you sit the exam, and ones that you need to know really, really well because you're going to be asked questions about them. Okay, it's also an open response type question, which means that we're not looking for any quality of written communication, we're not marking you on your language, you can just jot down ideas as bullet points. We are still looking for certain specific keywords though, and we are looking for clarity of writing, because clarity will mean that you're more likely to get given the marks, okay, more likely to express yourself well and then get given the marks. So have a little look through this one. This one is about the practical to do with calculating the specific heat capacity or measuring the amount of energy which is transferred to this block. We'll say one more thing about this one before you maybe pause the video and have a go, is that even though it's open response and it's meant to be a worded answer, it refers to and uses some equations from the GCSE Physics. A lot of the time, even if they're open response questions, the equations are still going to help you solve the questions in physics. So when you approach open response questions, firstly think to yourself, what knowledge do I have that I can apply to this? What do I remember? What do I understand that I can apply to this situation that I've been given here? Okay, this is a calculation question. So after you've read it and figured out what part of the syllabus you need to apply to it, then you should probably go through and identify what the data is, what it means, select your equation, rearrange, input, calculate, and then check. The other thing to always be aware of is, are the units coherent? Do they need any conversion? So this is the first part here, have a go at that. And then this is the second part here, which you can have a go at as well. Remember, one thing that's really important in the new GCSEs is that you remember those equations. You get given some equations, you do get given the equation for this one, but you need to remember the equation for this part here. Last one here, this is a level of response question, and probably your teachers are used to referring to this as the quality of written communication, or the extended writing question, or probably just a 6-marker. 6 markers in science have been a big deal in the last syllabus, and they're back for this one here. So there's a real knack to answering this question that I want you to be really careful about. So read it together. A student rubs a balloon against a scarf. This little stem of the question, this gives you an idea of the content to apply to it. So before you even think about it, drag up from your mind, what is this all about? Aha, it's all about static electricity. There's some key bits that I'm going to need to apply about static electricity to this. Describe how the balloon has become charged. So the first thing I need to do is describe something, then suggest a way to show the balloon is charged, and then what would you expect to see and why? Okay, I've underlined those because those are the kind of command words that tell you what you are being told to do. Before you start writing one of these quality of written communication or level of response answers, which are indicated to you in this syllabus, OCR Gateway, by a asterisk here. So you're going to see the asterisk and think, aha, I know I need to tackle this slightly differently. I know I need to plan. After you've applied your content, make yourself a brief plan. And the way to do that is to look at the different parts of the question. Firstly, this part, I'm going to describe how the balloon has become charged. Then I'm going to do this part, suggest a way to show the balloon has become charged. And then I'm going to do this last part, what would I expect to see and why? And if I do that, 1 paragraph, 2 paragraphs, 3 paragraphs, I'm much more likely to get 6 marks. So essentially, you can just think to yourself, in these level of response questions, what are the little mini questions that go to making up that full 6-mark question? And always after you have answered it, then check back, have I done what I planned to do? Have I covered everything? Have I used any of the detail that's been given to me in the question? I hope that was helpful. It was really, really useful to know how to approach different types of questions. Remember, each one starts with remembering and applying some knowledge. So you have to know your specification really, really well. You need to know your way around it. You need to know what you're expected to remember. For example, you could not do a lot of those questions if you don't remember the equations. And you need to know how to apply that and be used to applying all that knowledge to a range of different, more difficult contexts.